Hi, everyone. This is Kyle Welch with RCR Wireless News and Enterprise IoT Insights. And on today's webinar, we'll be discussing the opportunities in IoT deployments, the challenges in connectivity in industrial settings, and the opportunity that private MulteFire and LTE networks provide. To lead the conversation, we are joined by Alex Glaser, Director of Development at Harbor Research, and Mazen Chmaytelli, President of the MulteFire Alliance. At this time, I'd now like to pass the presentation over to Mazen to get us started on the discussion.
Thank you, Kyle. Hello, everyone, and good morning from the West Coast. This is Mazen Chmaytelli. I'm the president of the MulteFire Alliance. I'm looking forward to this webinar. I could go ahead and cover MulteFire's technology as well as the latest on the MulteFire Alliance. Also, I'm delighted that Alex is joining me from Harbor Research, and he'll share with you the latest research he has on that topic. So let me begin by discussing what MulteFire technology is and how it started. So basically, about a few years ago, the MulteFire Alliance was formed back in late 2015. And the reason for forming it, including the founder company, which is Nokia, Qualcomm, Ericsson, and Intel, was to put together an LTE-based technology that provides the key LTE characteristics, however, enabling that technology to run in unlicensed spectrum or shared spectrum, basically removing the requirement of having an anchored channel, an anchored spectrum to run LTE in that band. What this provides, what I think of it is best of both worlds, being able to get the key characteristics of LTE, however, looking also at Wi-Fi-like deployment simplicity. So being able to provide this technology that can benefit from both LTE-like performance as also Wi-Fi-like simplicity, which this means it provides industrial IoT and private LTE networks with enhanced data and voice services, enabling local deployment. Also, it is suitable for any band that needs contention-based or over-the-air contention. So basically, MulteFire is designed from the get-go as a technology to work in unlicensed spectrum or shared spectrum, where fair sharing and contention-based mechanism are needed, and that's how MulteFire was designed. Also, since MulteFire leverages LTE release 13 and 14, and I'll speak about that in an upcoming slide, it does leverage the LTE ecosystem. So basically, it broadens the LTE ecosystem to target specific use cases and applications, as well as markets for enterprises, industrial IoT, and enable cable operators, as well as operators that don't have licensed spectrum, to deploy LTE-like technology based on MulteFire. So what are the LTE-like key performance characteristics that MulteFire brings as a technology? So if you think of it, MulteFire will allow anyone to deploy their own private network, leveraging unlicensed or shared spectrum. By doing so, MulteFire provides key characteristics such as better radio coverage, enhanced capacity, seamless mobility, increased robustness, and enhanced security. So I have a few of these listed on the slide. Also, one thing to keep in mind that since MulteFire is designed as a new air link, leveraging release 13, there are also different mechanisms of deploying it or architecture from an architecture perspective. So you could have it SIM card based or non-SIM card based, depending on how the deployment needs to be offered. So what I'm trying to highlight on the slide, there are key performance advantages, but also there are also some flexibility depending on the breadth of your deployment from a private network perspective. I mentioned that MulteFire leverages 3GPP release 13 and 14. Let me dig deeper into that. So if you look at this slide, you could see basically the MulteFire Alliance roadmap. I'm happy to announce that release 1.0 was already published. It's available actually publicly since April for everyone to download from the MulteFire Alliance website. So if you look at MulteFire 1.0, the way the spec is written is actually a red line on 3GPP release 13 and 14. So as 3GPP started defining LAA and ELAA, which enables LTE to run in 5 gigahertz unlicensed spectrum band, what MulteFire did is leverage that work, however, remove the requirement to have a licensed anchor from a spectrum perspective. This way, MulteFire 1.0 enables new deployment opportunities, either in unlicensed and shared spectrum. Now, since we released MulteFire 1.0 from MulteFire Alliance perspective, the team have been working hard on the next version of MulteFire, which is release 1.1. That release is very important for this discussion today because we're focusing on IoT. So release 1.1 does expand the MulteFire capabilities into IoT support, leveraging as well 3GPP release 13 and beyond eMTC and NB-IoT features. And of course, I put all the way to the right side of the slide is what's happening beyond 1.1. As 3GPP move into the 5G definition, there are already study items regarding 5G NR and unlicensed band. Similarly, 5G MulteFire will be running in parallel to enable commercialization of 5G-based MulteFire into the future. So release 1.0. So the goal, once the MulteFire Alliance was formed in late 2015, was to come up with an end-to-end specification enabling MulteFire to be deployed from an end-to-end network perspective. And the goal we set up as an alliance to have that spec completed within 1 year. And I give great kudos to the technical teams for meeting that challenge and being able to release it within 1 year. Release 1.0 was available to the MulteFire Alliance members in January of this year. And as I mentioned earlier, we made it available for public download in April. You could see the link, the last bullet on that slide, where you could download all 16 documents consisting release 1.0. So what release 1.0 offers is our first end-to-end release enabling LTE-based technology to run in unlicensed or shared spectrum. Specifically for release 1.0, the two targeted bands. First is the 5 gigahertz global unlicensed band that's supported in release 1.0. But also, while we were working on release 1.0, there were some activities in the United States regarding the CBRS band, or the 3.5 gigahertz band, which is set up as a shared spectrum band. Since MulteFire as a technology has in its DNA contention-based capabilities, it's very suitable to shared spectrum bands, such as the CBRS band in the US. Now, since MulteFire leverages 3GPP release 13 and 14, specifically LAA and ELAA capabilities, MulteFire from day one supports listen before talk for fair sharing and coexistence with Wi-Fi and other technologies using unlicensed or shared spectrum. I mentioned release 1.1 is an important release for today's discussion. So let me share with you how, from a roadmap perspective, release 1.1 is shaping up. So if you could look here at MulteFire release 1.0, as I mentioned before, it's targeted specifically for 5 gigahertz globally and CBRS band in the US. With 1.1, which we're working on from an alliance perspective, we'll actually have two means of supporting IoT capabilities. The first, first you'll be supporting enhanced machine communication, eMTC, and that will be supported specifically for the CBRS band, as well as Azure global or regional bands that's listed on top. And second, NB-IoT for low power wide area LPWA support and use cases. And that will be targeted for the 2.4 gigahertz global band, as well as other regional bands, depending on which country deployment operators are looking to deploy MulteFire. I also listed the carrier bandwidths between each flavor of MulteFire releases, so it gives you an idea what kind of bandwidths were targeted and why specific spectrum bands are applicable to which MulteFire release. So before I hand it off to Alex, I want to make sure to reiterate that private MulteFire networks enable new IoT deployment scenarios. So basically, by offering MulteFire, private LTE network will be able to use dedicated equipment, allowing it to be independent of traffic fluctuation in the wide area macro network. These private LTE network can be tailored for more optimized performance, providing local control, optimization, depending on your use cases, and a few of these use cases Alex will cover next. And lastly, Release 1.0 is available right now publicly, so you could see vendors and interested operators starting to look at what kind of deployment model they'd like to leverage that technology for. I'm going to go ahead and hand it off to Alex right now so he could cover his latest research on this topic.
So first off, thank you to Kyle and Mazen for having this opportunity to speak about our research. But before I get started, I just wanted to give a brief overview of Harbor Research. So we're a research and consulting firm with offices in Boulder and Zurich, and we're really focused on looking at identifying and validating new growth opportunities informed by the Internet of Things. This research is going to look at the private LTE opportunity for industrial and commercial IoT. So what we did was we used our Smart Systems Forecast database, which is 450 connected device categories across the economy. So that's anything from like a connected light bulb in a home to a turbine in a power generation factory. And what we did is we scanned all of those environments to look for mission critical or operationally intensive segments. So what we mean by that is anywhere where that device or the data off of that device is critical to the operations of that environment. And we were able to go from about 5 billion devices in 2017 down to 1.5 billion by just looking at those operationally intensive environments. From there, we went in and we started looking at devices within those environments specifically that had several characteristics. They required high network reliability, high bandwidth, low latency. There was a high density or potentially a high node count, strong potential for value add into the overall operations, high mobility, high interrelation of devices, and strong adoption. And so when we were looking at these different devices, what we were trying to understand is, for example, in a port, an overhead hoist crane is very critical to the environment. It's the main device that moves equipment off of a ship into the port so that the processes can kind of transfer over to getting those different containers and things like that onto the trucks and off onto the road. From there, what we did was once we identified those environments, we started to look at higher value devices and tried to think about the potential for private LTE and how it could be applied in these different environments. So when we got done, it was about 170 million devices growing out to about 765 million devices that could be addressed in this type of environment. So after we looked at those devices, and at the bottom of the screen, you'll see the requirements addressed by private LTE. So that reliability, throughput, low latency, mobility, things that we talked about. What we started to think about were applications that need this type of connectivity or this environment. And so what we did was we started looking at these different applications, and I'm going to deep dive into several of them here in the following slides. But at a high level, things like worker safety monitoring or operations visibility and optimization, remote diagnostics, predictive maintenance, asset management, authentication and access control. These were applications that we said, okay, with this type of network that we haven't seen before from a wireless standpoint in these commercial and industrial segments, how could we maybe apply them? So we started looking at places like manufacturing, power generation and utilities, public venues like transportation, airports, for example, natural resources, remote environments like offshore drilling, or you think about mining environments in the middle of Alaska or Africa, dispersed supply chain and warehouse environments, or hospitals. And so the research started to really look at ancillary data services that we can leverage in these environments across a series of applications where, private LTE or private IoT networks can really provide that reliability and throughput that we haven't seen from other wireless networks in the past. So if I talk a little bit about some of the segments that we kind of, as we were doing the research, kind of popped off the screen for us. Several of the things that came to mind we're thinking about like hospitals and labs. So traditional wireless networks have had trouble with all of the concrete or the bandwidth requirements from both the hospital side, but also from the residents who are staying in the hospital for providing the wireless networks that can actually meet the needs of the equipment, but also the users. But then also, you know, many other areas came to mind. So when you think about like an airport, a plane lands, instead of having to dispatch a technician to run out to the plane and get the diagnostics data, with this private secure network, I could actually do an offload of that data while it's pulling into the gate so that I could run diagnostics and have repairs going on, you know, during the boarding, onboarding, and reboarding of the plane. Now, this is another example where we've heard of this kind of use case in many other instances, but what we believe is that MulteFire, you know, with the private IoT LTE kind of approach, will allow for that reliability and security that we may not have seen with other networks. Other areas that we've thought about were remote areas where you may not have access to public networks like remote mine and things like that. So if I jump forward, the next piece is really, why do we need this type of network? And the reason is because there's a series of what we would call compound and complex applications. So a simple application in our estimation is something like an alert that, you know, a tire might be spinning 4 revolutions per minute faster than it should. A compound application, and this is kind of where we're starting to go with IoT, is being able to do, for example, service orchestration. So I know that I need to repair 15 types of devices on a manufacturing floor, and I want to orchestrate when and how all of those maintenance engineers can conduct that maintenance in a very orchestrated fashion. So I'm going to work with the team to be able to understand the data coming off those devices in real time, to be able to understand which devices, when, who, what, where, and how. Complex applications might be thinking about operations visibility across an entire city, from port to transportation infrastructure to driving and things like that. And so when we think about the different applications that can be served by or enabled by private LTE, some of them that come to mind are, for example, remote diagnostics and predictive maintenance. So I want to look at power transmission equipment. I want to look at AGVs and forklifts, or robots and handling equipment. Another one that is important would be operations visibility, as I was just talking about. Imagine being able to drive throughput from the time a ship enters a port to the time that it leaves. We would be able to understand very quickly, you know, what's the most efficient way to get a container off of that ship through the overhead hoist crane onto a truck and to its destination. And again, all of those, you know, time that is wasted where a container is lost or it's not in the correct place, that's money to the port operator. And so we're trying to reduce the cost of the port operator and increase their margins. The last one I'll talk about is asset management. So if you think about more complex machines, when we think about devices and machines, it's all about being able to understand the data in real time, but also ensuring uptime. And so if I'm able to predict or understand, you know, whether it's maintenance schedules, parts management, who was the last, you know, maintenance engineer to actually conduct the work on that machine, all of that information being served up while being able to look at how the machine is performing, that's going to really improve our operations and drive our costs down and increase our efficiencies. And if I'm a product manufacturer, what that's going to do is that's going to enable new services I can provide to my end customers that could potentially differentiate myself from other OEMs or other product manufacturers. So if I move forward, one of the things that we looked at was the market sizing. And so just so everybody's aware, what we're looking at is devices that can either be connected, you know, traditionally today through wired or wireless technology. So whether that's a traditional wired technology or a wireless technology, what we're trying to understand, you know, how is it that a MulteFire network could come in and actually improve the performance. And not only that, would the customer want to leverage it? So when we talk about addressable devices, we're talking about devices that would be suitable and more likely perform better, and the data and the applications that could be served off of the device would increase our operations and things like that. So when we look at the opportunity in 2017, we're seeing about 170 million devices that could be addressed, growing out to 765 million devices at a 28.4% compound annual growth rate. Now, again, this is really just looking at industrial and business critical environments. We weren't looking at consumer devices or things like that. So moving forward, if you look at the actual revenues, so everything that I've talked about up to now is about the devices themselves. So when I think about shipped or installed devices, what I'm talking about are devices that are connected to the internet. And now what I'm going to shift to talk about a little bit is about the revenue opportunities. So on the right-hand side, you'll see a pie chart. So on the right, you'll see enablement. That is really looking at the cost of connectivity or silicon that's enabling the device through LTE and MulteFire. If you think about network services, this is the area where, like a Verizon or an AT&T or a Nokia, any of the operators who are trying to actually, or carriers who are trying to provide the network and the revenues that can be obtained. So that's about 22% of that 118 billion. System applications really look at the actual, the platform or the device management capabilities, other things like that. Sorry. And then value-added applications. So when we were talking about the value-added applications, on the previous slide, we were talking about asset management. We were talking about operations visibility. All of those are kind of represented in this 59.89%. So roughly, 60 million of the 119 million. When you think about, the growth over by 2023, we're estimating $119 billion. 58% of that would be in those applications that are enabled by this network. So if I break out that same 119 billion and I break it out against the segments that come up are things like factories, mills, warehouses, plants. And so warehouses is really a big piece of that shipping ports discussion we were talking about before, because they tend to sit off of the ports. You think about upstream, midstream oil and gas. Power transmission. The reason that power transmission is such a large opportunity is two reasons. One, it's very operationally intensive. So they haven't seen a network today that is reliable beyond doing ancillary data services. And then the second is just the sheer number of equipment required in power transmission and distribution. Other areas that we look at, and I'm going to jump into a couple of case studies here in a second, but other areas that we look at are, places like mills, factories, and and plants, which are really discrete, hybrid, and process manufacturing. And so when we think about those process and discrete manufacturing segments, there's a huge opportunity there. But what I want to do is just spend a couple of minutes talking to you a little bit more about our example of a shipping port. So in 2023, we think that there's going to be about 22.8 million units of a revenue of about $2.4 billion when we take all those revenue categories. So enablement, network services, system apps, and value-added apps. Specifically in value-added apps. So when we think about the challenge, so I talked about this earlier, but it's increasing container traffic through the port, because really congestion is not only lowering, the amount of containers we can ship through, meaning the more money we can make, but it's also straining the assets. So whether that's the overhead hoist cranes, the AGVs, the different equipment that's required to operate a port. So a solution is that the private LTE network could support the environment by providing kind of a secure automation of mobile equipment and the port, while also providing that level of security necessary around the equipment and the goods moving through. When you think about character recognition, you think about remote monitoring. So for example, on the right, you see that overhead hoist crane. Those are one of the most important assets. If we think about one of the other biggest pieces for a port is loss prevention. So whether that's through theft or just misplacement. So having the ability to leverage security cameras to do identification, but also real-time surveillance. And then the other piece would just be looking at automated guided vehicles. So as we move more into autonomous vehicles, we're able to actually see the ability to streamline the operations of the port by being able to really drive home, the efficiencies, but also the reliability that private LTE can provide. And so the network itself can be deployed across many of the, so for example, if you think about a given port, they might have 8 different operation centers. Imagine being able to deploy a single network instead of having to have 8 different networks, so that as devices move across those, we're not having to provision and commission those devices each time. The next case that I wanted to talk a little bit about is what I was mentioning earlier around the mills and factories. So this is an example of a factory where off to the right, you'll see that the network would be able to provide for employee tracking, automated guided vehicle monitoring and control, but then again, overhead hoist cranes. So this brings me to a point that I wanted to raise. There's a series of horizontal devices that sit in many of these industries. So whether it's automated guided vehicles, cranes, other pieces of equipment that are really important to identify because they could be automated or connected via this network in many of these segments. Again, security and surveillance, asset management. But the thing I just wanted to point out is, you know, when we think about manufacturing facilities, many times, if you go talk to systems engineers in these environments, there's a big fear of leveraging wireless because of its interference, because with control networks, because of its ability to work through many of the steel and concrete structures. And then also just the size of these facilities. Many of these facilities are many hundreds of thousands of square feet, and having to deploy many access points is a bit strenuous when I could just deploy a private network that would allow for a seamless integration of all these devices. So again, in this instance, manufacturers are trying to improve operation efficiency while reducing downtime. The solution here is thinking about private LTE enabling those key remote monitoring. So imagine if I have many different sites and many different devices, being able to look at how all of these different devices are integrating across all of my sites and being able to make sure that I'm increasing my uptimes and operational efficiency across many of those sites is important. From a factory standpoint, we see private LTE as a market at about 128 million units in shipments alone in 2023, with a revenue of roughly $18 billion from smart systems. So the opportunity itself is large. I don't think there's any question that IoT is going to infiltrate these environments. I think it's a matter of which technologies, and through our research, we see private LTE as a strong candidate to be able to provide that networking layer that these environments have been missing over the last 5 to 10 years. So moving forward, this is a chart that's kind of looking at, as I was mentioning earlier about simple and compound and complex applications, okay? What you want to think about is the ability to the network to be able to take on or penetrate those environments based on performance. So industrial IoT and automation technologies drive demand for this wireless need around what we're calling ancillary data services. In order for private LTE with MulteFire to be adopted, it has to show sufficient and effective network capabilities, such as like seamless interoperability and integration with existing technologies. And so as that happens, there's sort of two paths. We can either have like a delayed uptake where industrial solutions don't alleviate the wireless solutions don't alleviate the problems or concerns around security and reliability and throughput and latency, or they do. And that's kind of the scenarios that we've laid out. And in our opinion, this is the first network in a privately deployed fashion that we believe can actually address the security, reliability, throughput, and latency standards. Now, it's still early in the game. I think the MulteFire Alliance has done a great job of getting the standards published and getting people involved. But as time goes on, it will really be up to the end users, the operators of these environments, to work with these technologies to evolve them and drive the adoption. So the last piece or conclusions from our research that I just wanted to highlight is that we believe that there's a whole new generation of wireless networks that are needed for sensor enablement, mobility, and edge intelligence. So everyone out there today is talking about, well, we got to push, intelligence to the edge. We got to make decisions at the edge. Well, you're going to need a network that has the bandwidth and the reliability to do that. And so we believe in order for those types of needs to occur, we need to be able to have a network like private LTE with MulteFire to do that. As we've talked, kind of heavily about, we believe that the opportunity is large in size, both in devices and revenue. So whether it's the $119 billion in revenue or the 760 million devices, either way you cut it, it's a large opportunity, and we believe that this is like one of those instances where it's a tidal wave. You can't really avoid it. It's coming. You're going to have to address it. It's just figuring out how you're going to do that and who you're going to partner with to do that. The market for wireless managed networks within mission critical segments, we believe areas like transportation, like the airport I mentioned, supply chain, energy because of the large amount of devices in the operational intensive environment, and then also industrial manufacturing, so oil and gas, mining, even healthcare in that sense. We believe that as these markets continue to adopt IoT, the customers' requirements around applications and use cases is only going to continue to increase, and so, or become more challenging. And so it's up to networks like private LTE with MulteFire to be able to provide that, like I call it, the information highway, the infrastructure for communications to be able to allow for the data to be transferred to run those applications. Lastly, before I pass it back to Mazen, is looking at the attractive applications. So when we think about attractive applications for private IoT networks, many things that come up to mind are safety monitoring, security and surveillance, maintenance and service orchestration, and then lastly, mobile equipment automation. And the one thing I'll leave you with is that, if you look at distributed environments like a mine or a shipping port or a manufacturing facility with many pieces, it's really important to remember that traditional, networks like Wi-Fi have not been able to provide the performance requirements needed in many of these environments. Now, that's not to say that Wi-Fi won't improve over time. It just hasn't in the past. And so many users are looking for new networks or new capabilities. And I think that's why you've seen things like the emergence of LP-WAN and NB-IoT, as well as private IoT with LTE, because customers are really looking for those new networks that can really be reliable, secure, but also provide the bandwidth and throughput necessary to run a lot of these operations. So with that, I'll hand it back to Mazen and let him finish up the rest of the presentation.
Okay, great. So I'm happy to announce that Harbor Research white paper detailing the private LTE opportunity for industrial and commercial IoT is available right now on the MulteFire Alliance website. I posted the link there for you. One thing to note, this white paper was jointly commissioned by the CBRS Alliance and the MulteFire Alliance. So he covers the full aspect of our discussion earlier today. Also, I want to take a few moments here to have an outreach regarding MulteFire Alliance membership. We've seen uptick in membership requests when release 1.0 was made available. So I'm happy with that trend. So again, from a background perspective, the Alliance was formed initially as an independent member-driven consortium following 3GPP ETSI style organization from a standards perspective as well as IPR policy. The goal here is to have these like-minded companies work swiftly together, as we've done with release 1.0, to get the spec available and have this technology widely deployed. So again, if you go to multefire.org, there's a link there to submit your application. Eventually, it'll reach me and the executive committee, and we're pretty quick usually at making the reviews and accepting new members, assuming they meet the requirement. So I'm happy to say we're now 32 members. I listed the membership on the next two slides. So as I mentioned initially, Qualcomm, Nokia, Intel, and Ericsson were the founders, board members of the Alliance. Later on, Huawei joined, as well as Cable Labs, and recently Boingo was elected to the board. So you have diverse board membership there listed in these 7 companies. The full membership base are listed here. The recent companies that joined, Sony and Samsung, you also see, as well as American Tower. From a membership perspective, you have small cell vendors, vendors with Wi-Fi background, as well as the tier 1 US cable companies, as well as Liberty Global on the next slide as members. We have various levels of membership, as I mentioned. So from an adopters members perspective, the recent joiners are Foxconn and Sierra Wireless. As I mentioned, Liberty Global from a global cable company perspective. And also, the entire ecosystem is represented from these 32 members. And last but not least is the test lab and test equipment participants, starting with Rodi and Schwartz, and recently and Sanjole, and recently DECRA and CAICP in China. All these members are listed on our website, and we get membership requests on a weekly basis. So keep checking, because we keep adding more members as things progress. So lastly, I want to wrap up before opening it up to Q&A is, MulteFire is a new innovative technology that really trying to leverage the best of both worlds, as I mentioned initially, between an LTE-like performance, but also being able to look at the Wi-Fi simplicity of deployment and bringing this together to industrial IoT applications. So with release 1.0, anyone is able to create and install their own private or neutral host network. I mentioned the enhancements in terms of coverage, capacity, mobility, as well as reliability and security. We're working hard on release 1.1 to add additional bands to support, as well as IoT optimization. So overall, we're looking at new opportunities for industrial IoT that benefit from this LTE-based technology. With that, I'll hand it back to Kyle for Q&A.
Thanks, Mazen. We've had a lot of questions come through, so we'll jump right in here. Mazen, so I think first question is for you. So you talked briefly about the private network and private handsets. So who provides those handsets? And can the handset work with LTE as well as private networks?
Yeah, thanks, Kyle. Great questions. So as I just covered the 32 members within the alliance, what I'd like to do is, as an alliance, we don't comment on specific product plans and product roadmaps. We refer to each vendor specifically. But what I could say, as you see, from the initial formation of the alliance, you have two large infrastructure vendors as well as chipset vendors represented. And you could see throughout the membership base, you have handset providers represented as well as chipset provider for the handset side. Now, since MulteFire leverages LAA and ELAA, the question would the same device support 3GPP LTE as well as MulteFire? My answer would be depending on the requirements and the vendor specification, but I would envision such device to be available because there's a lot of leveraging between LAA, ELAA, and MulteFire. So you could see multi-mode devices if that addresses the question.
Right, great. And the next question for you is, when is the MulteFire Spec 1.1 expected to release?
We're targeting the initial release of 1.1 to be available to members, to the MulteFire Alliance members, by the end of this year, 2017.
Okay, perfect. So the next question we had come in is, what steps need to happen to see MulteFire deployed in an industrial IoT setting?
Right. So what I say is, what you like to do is basically look at the specific industrial IoT requirements and work with vendors to have the end-to-end products and deliverables available to set it together. Now, the flexibility of MulteFire allows various architectural models. You could have it done as a neutral host architecture or as what I call the PLMN access mode, which enables tight integration with the macro MNO network. So you could have this hand in and hand off between both. But with release 1.0 today, once products are available, and once you meet with vendors, you're able to go ahead and set together what network model you'd like to do and how you want to deploy it.
All right, great. And Alex, looks like we have a couple questions addressed towards your presentation. So to start, you talked earlier about device forecast. When looking at that, what is assumed for the amount of data that these devices are generating?
Yeah, that's a great question. And for anybody who's interested, we do have kind of data requirements per device. But for example, we were just looking at a wind turbine, and I think it was like 200 gigabytes per day that's produced. And so just the bandwidth to be able to support that amount of data produced is extremely high. The other thing I would say is it's not so much about one individual device. It's when you start compounding many devices, the data produced off of these systems is extremely high. And so if I'm like in a bottling factory, it's all of the robots plus the material handling systems sitting underneath that I'm trying to orchestrate all of that data to drive clear understanding of the operations and how to drive efficiency in those operations.
All right, and the next question, Alex, we'll start with you and then possibly have Mazen chime in. So can you talk a little bit more about the differences between a private LTE network and Wi-Fi and possibly some of the strengths that lie there?
Yeah. So first thing to point out would just be, range. So being able to extend the range with LTE is one thing. But two, when you think about the ability to deploy, one of the things that we've talked to the MulteFire Alliance about is it's easy to deploy these networks, and I'm not having to deploy 15 access points in one warehouse. So I'm able to actually easily deploy the network. And then the last thing I think is really important is security and reliability. And so when you look at the performance metrics, and this is one of the big things that we spent some time when we were screening all of these devices, is really trying to look at the performance metrics and really understand, what is required and what is being delivered today. And I think that's a lot of the reason you have seen people stick with Ethernet in many of these environments, because the problems that they were facing with Wi-Fi. And sorry, one last point would just be potential interference. So when you think about Wi-Fi in a automotive manufacturing plant, we talked to one plant engineer who said that just the fear or the risk of interfering with the control networks is too high to try and pose to deploy a Wi-Fi network in that environment. Whereas when we talked about kind of a privately deployed network through MulteFire and things like that, they were open to it because of the kind of separation that can occur and things like that.
Yeah, Alex covered it well. What I also would like to point out, the MulteFire Alliance website, there's a link for all white papers, and we have a detailed technical white paper on release 1.0, which highlights these key performance advantages of MulteFire within the white paper. We also recently, as earlier this week, translated it into Chinese as well.
And Mazen, we've had a couple people ask questions about accessing these white papers. I do want to let everyone in the audience know that we will be sending a follow-up email after this webinar, and we'll be sure to include a link to that webinar. White paper library. All right. So the next question we had is around field trials. I think Alex, that's something you touched on a bit. Can you kind of walk through, the process in starting a field trial around MulteFire?
Well, how about this, Mazen? I'll take the high level, and then you can take the technical. Is that fair?
Right, and I'll touch on timelines as well. Yes.
Okay, great. So from a high level, I think where we've seen success with companies is when a product manufacturer is aware of an end customer's problem, brings it to that end customer, and then that end customer says, "Holy moly! If not just your device, what about all of these devices?" So, there's been specific examples in ports and manufacturing facilities and mines where an OEM will come in and say, "Hey, we can provide you with a different type of network that will provide different type of performance," and then the end customer's eyes sort of open up to all of the possibilities that are available, and then it's really on the suppliers to provide that end customer with the kind of reliability or network to enable those applications that they're looking at. And that could be anything from operations, visibility to asset management and so on. But Mazen, I'd love to hear a little bit more about the actual nitty-gritty and detail on that front.
Right. So right now I want to touch on timeline as well. So what we're looking at from a MulteFire Alliance perspective is to have the certification program up and running, which certify both the small cells access point side of MulteFire as well as consumer devices, available by the end of 2017. So that would be the full certification framework, testing plans, etc. With that in mind, we're anticipating to see lab trials happening towards the end of 2017, followed by field trial in first half or early 2018. Now, I think you covered the key aspects, Alex, of what's needed to do a trial. So initially, I would suggest to go ahead and work with the vendors that are part of the MulteFire Alliance membership base to provide you with the equipment, either on the infrastructure side, light EPC core, as well as on the devices side. Once you coordinate with the vendors, then you'll have a field trial running, and then you could assess what exact characteristics you'd like your MulteFire network to handle, and then that would be put together. So it's the same as deploying a network, basically, where you have to sit together with your vendors, understand exactly how you want to deploy it, and go ahead and plan the deployment out there.
All right, thank you guys. So Mazen, next question looks like it's directed towards you. So will it be possible for regular mobile phone with only one SIM to use a private LTE network? If so, how does the device authenticate with the network?
Right. So the way the MulteFire architecture, the general design principle on the architecture side of MulteFire enabled two reference architectures. One is neutral host network model, and another one is PLMN access mode. Now, with the PLMN access mode, the MulteFire radio network will connect to a 3GPP MNO network core. So as an additional access network for the PLMN. So you'll have mobility with IP address preservation provided between a MulteFire network and the 3GPP RAN network. So with that architecture, you're able to hand in and hand off between the macro network and the private network and back and forth. So that's also available in the system design from release 1.0 onward, of course.
Next question will go to you on Alex. So many of the industrial applications can be addressed today by wireless broadband systems operating in unlicensed bands. Can you talk a little bit about the advantage of an LTE-like solution?
Yeah, so I think LTE and specifically MulteFire has proven more effective reliability. And when you think about that potential for interference that I was talking about, that's another big advantage. And then the other thing is just the overall fact that the network, the throughput performance is much greater. And then the last piece would just be around range. So being able to leverage this networking technology in a way that is much more suitable for environments where range is a question and things like that, and mobile devices are in play. And by mobile devices, I mean devices that are moving, so not like your cell phone, but things like an AGV or other automated guided vehicle, like a forklift and things like that.
That's a good clarification to make there.
Yeah.
Perfect. Yep. So next question from Mazen. So I talked a little bit about chipsets and modules. With those, it sounds like they're agreed with the vendor. Can you talk a little bit more about kind of the process in chipsets and working with vendors with MulteFire network?
Right. So again, a specific chipset plan and roadmap will be referred to the specific vendors about their plan. What I could comment on is so far the MulteFire Alliance have seen key members within the alliance looking at having lab trials happening end of this year, as well as field trials in early 2018. So it's the same process as an LTE ecosystem, where you have chipset provider works with device manufacturers and when I say devices, again, the same definition as Alex, could be module providers that could be within an industrial IoT device or machine. So same thing as the 3GPP ecosystem offers chipset to various vendors and module providers, the MulteFire Alliance members will do the same from that perspective.
All right, great. So we had another question. So which industrial IoT segments will deploy MulteFire first?
Alex,
so I think, yeah, that's fine. I think it's a good question. It depends on how you look at the Internet of Things and which segments will kind of deploy Internet of Things technologies first. So areas like manufacturing that have complex environments, high costs, and they're trying to drive efficiency will be kind of on the higher end of the adoption spectrum. Other areas that come to mind, we mentioned on the slides, were things like power generation, supply chain. We're seeing some movement in oil and gas, both upstream and downstream. So those are some of the top segments. But the one thing I would just call out is that, I don't think it's which segment first or second or third. I think it's a matter of just understanding that all of the segments will then eventually adopt. And we're talking in the next 3 to 5 years. And so it's trying to understand what are the key buying behaviors you're trying to address in those segments. So whether that's cost to deploy or whether that's looking for reliability in the network, or in some instances like healthcare, security is a big issue. And so being able to provide a secure network for transfer of patient data from an MRI machine into their files, things like that. I mean, we were talking to one MRI manufacturer, and in one film, they can shoot up to 20,000 pictures per second. And so it's like 250,000 pictures over the course of a minute. It's insane. And so being able to leverage a network that could actually provide that transfer in those environments to secure is definitely pertinent. And so that's why we see all of these segments eventually adopting. But as I mentioned, things like manufacturing, mining, oil and gas, energy, supply chain, those are some of the areas that rise to the surface in the early terms.
Okay, next question we had come in. So kind of goes with talking about vendors again. So how will the vendor community support the rollout of MulteFire networks, and what devices will be required for that?
Right. So I think I already, as I mentioned previously, it's basically you work with various vendors. You need access point or small cells that support MulteFire on the infrastructure side. So you'll work with the various vendors. Some of them are part of the MulteFire Alliance right now. Also, you'll need modules for the Industrial IoT to go into the various devices that Alex specified. So the chipset provider that provide modules for LTE will look at providing MulteFire chipset as well to support these categories. Now, of course, there's MulteFire 1.0, but also there's the various flavors of 1.1, which I covered earlier. So you'll need to look at what type of deployment, which band you're targeted, and also what architecture. Would it be a standalone private network, MulteFire networks that's running in a neutral host model, or you'd like to have interaction back with a macro provider? So all these would be basically discussed as part of deployment model, first from a trial perspective and then into commercialization.
And just one comment, when you think about these environments from a commercial and business standpoint, there are a lot of systems integrators, value-added resellers, automation providers who have an influence of how these systems are spec'd. And so it's also important to keep those types of players or companies in mind when you're thinking about deploying, because they can help kind of advance or figure out which modules to purchase, or what the topology and setup needs to be based on a different if you have many sites and things like that. So I just wanted to comment on that for to bring in the fact that there are many people within the ecosystem who can help drive the adoption.
All right, thanks. Mazen, can you, are there any specific MulteFire deployments or any trials you can talk about specifically?
Nothing announced publicly regarding what's happening towards the end of this year and early 2018. There were a couple of announcements about from various MulteFire Alliance members about live demos and live demonstration. I recall Nokia mentioned a demo of MulteFire with Saudi Telecom. I know Qualcomm did a live over-the-air MulteFire demonstration that was shown live. It was run in San Diego, but shown live at Mobile World Congress in Spain earlier this year. So you could see each vendors that are members of the MulteFire Alliance already showing some demonstration of the technology. Also, whenever we have an open day event, we just held one in Beijing. Huawei hosted the MulteFire Alliance, and various members of the alliance were showing demonstrations that included the test equipment from Sanjole as well. So I would say there's a lot of demonstrations going on, and as far as lab trials and field trials, nothing public that I can comment on right now.
Okay, thanks. Kind of as a follow-up with that, it seems like there's a lot of trend moving towards the MulteFire networks and utilizing that. What about certification? How can people be prepared to work with the MulteFire network? Are there plans for certification?
Yes, absolutely. So about mid last year, the MulteFire Alliance established a certification working group, and that team's been working on defining the framework for certification and related test plans. So they are targeted to have the certification program finalized, including test plans, by the end of this year, which aligns nicely with the field trial plans in early 2018.
All right, thanks. Looks like we have time for just a couple more questions. So the next one, I believe Mazen, probably start with you on this one. So how will the 1.1 expanded IoT capabilities complement MulteFire's 1.0 broadband capabilities?
Great questions, and that's why I actually listed that slide, which give you the channel bandwidth as well as which spectrum bands are available. So it goes back to on what type of deployment an operator would like to have. If they'd like to have a broadband deployment, then 1.0 is available today to offer 5 gigahertz and 3.5 gigahertz band support. 1.1 will add additional optimization to IoT. So if you're looking specifically at eMTC or NB-IoT type of deployment and unlicensed or shared spectrum, then there are some benefits to leveraging 1.1 because it did add additional bands and optimizations over 1.0. But they're not, it's not an either or kind of deployment. So 1.1 will carry forward with the 1.0 capabilities.
All right, great. And looks like we have time for just one more question. And we'll take this to both of you guys. So we'll start with Mazen and then hand off to Alex. So obviously 5G is the phrase of all phrases right now. Can you talk about how MulteFire will support the evolution to 5G?
Sure, let me start with that. Now, I would say MulteFire technology is already stepping stone to 5G. Because it already supports many of the 5G use cases. Now, with release 1.0, it did play a key role in the evolution to 5G because it pioneered a technology that enables standalone unlicensed operation. So we were really happy to see 3GPP study item looking about 5G NR shared spectrum as a study item within 3GPP. So I would say MulteFire or 5G-based MulteFire will go hand in hand with the evolution from MulteFire 1.x, which is an LTE-based version of MulteFire. Now, by supporting 5G type Airlink, you'll have additional use cases that would be targeted to specific industrial IoT applications, such as lower latency and additional capabilities that 5G will bring from that perspective. Alex, I don't know if you want to add.
Yeah, I would completely agree. It's a bridge, and as we begin to kind of scratch the surface of the applications that will be enabled by 5G, because I don't think we know what we don't know right now, I really see MulteFire acting as that bridge to be able to get into that new world of those different applications and things like that.
All right, great. That's about all the time we have for today's webinar, Delivering MulteFire Connectivity for Industrial IoT. I want to thank everyone for joining today's webinar. And I'd also like to thank our two presenters, Alex Glaser, Director of Development at Harbor Research, and Mazen Chmaytelli, President of the MulteFire Alliance. Thank you to both of you.
Thank you so much, Kyle.